computer audio. All right, so folks, the plan for today, and if you are watching the recording, I don't know, wherever you are, we're going to go over the checks for understanding from lesson 9 so that you can get the correct answers. And then we are going to do the explanation for the new project, the lesson 10 original scene, digital scene. Okay, which is critically important that you pay attention. Mostly, or a lot of it is, well, we'll talk about it when we get there, but the documents at the beginning of the lesson are not the documents we use, just in case you think you're going to scrub ahead to the end. Okay, so lesson 9, checks for understandings. We are going to go over the answers. There's zero excuse for not having them both completed and correctly completed momentarily. Okay, so the first one is identifying the abstraction. In this case, it has some very specific things that you easily could have got these wrong, this one wrong, because we haven't spent a lot of time dissecting the rubric. So I'm not worried, which is part of the reason we're just going to explain it now, because I'd rather have you know it now instead of having this be like a mini assessment to see if you learned it. You're going to learn it now. Okay, so here is the key to this. It needs to be a student created abstraction. The context is if you were submitting a project for the project in the spring, one of the components is your program code. And in that program code, you need to put a rectangle around an example of abstraction. And then you talk about that example of abstraction. They are asking you, which of these 4 is an example of abstraction? It's kind of a trick question because they all are. The question is, which one counts as a student-created abstraction? In order to know that, you'd have to know all the things that don't count, like using variables, existing control structures, which count as loops, and event things that code does for you. And we'll, again, in the spring, we'll figure it out in detail. But here, okay, the turtle movements, well, the correct answer is D. We'll talk about why the other ones are wrong. This first one, the move to turtle commands, they are examples of abstractions because they receive parameters and you can make a move to anywhere instead of having a single function for every move to location. It's an example of abstraction. It's not a student example of abstraction. This is a code.org function that's built in. You can't even see what's happening. Okay. Draw square is the function call for the function definition of draw square. And the call itself is not the abstraction. The abstraction is the function definition because you can use it a bunch of different times. That's what makes it simplified. So the answer is D, not to give it away. And C is not because it's just a loop, which is an existing control structure. Okay. The answer is D. It's the only one that is student developed would be the correct answer to that one. Don't copy that verbatim. Use like, I don't know, switch out a couple adjectives. I don't know. Okay. Level 2. Like I'm positive I said when we went over this the first time, I think this is the most difficult type of question that you will see in this class or AP exam, where you're given a chunk of code and asked, what will the result of this code be? What is wrong with this code? Which one of these chunks of code makes this shape? That sort of thing is difficult because you're not going to be in front of a computer programming it. You just kind of have to look at it. Spend enough time programming, it will be obvious, but you're not going to learn how to do this by cramming for it and just doing the bare minimum during the units of programming. You're not going to be able to cram for this. It will be easy if you do spend your time programming your own original stuff. But the key is that as you're going through this, you could look at, does this square receiving a size parameter work? one of the things that, well, part of the trick of this question specifically is that it asks for a line to be removed, not which line needs to be changed. That's even more detailed, that type of question, or that specific version of this question. But if we could look at the actual program, which I think I have here, this is that same program, has a high level function, draw 8 squares, that's called. The definition is a loop. The for loops look a little different. This is what the for loops will look like in the future, where they have more than just one field to type in, but it calls draw square, has a move situation, and draw square is the low level function. But if our goal is this shape, a bunch of squares in a straight line, and you call it the way it is, this is what it's going to look like. It's going to get to the end of, at each loop after each square, it's going to retrace the pattern. And it's kind of hard to watch the loops because of the way it bounces. At least, it's easy to watch to see what the square is doing. It's a little harder to watch the code. And this is even if you have the code, let alone if you're doing it on the test. The incorrect line is this extra turn right in the higher level function. Okay, so at the end of each square, it was making an extra right turn so that it would start the square pointing right and then do another square, and it would just kind of keep doing essentially what would it amount to 5 loops every loop. And so the answer was that extra turn right on line like 7. Okay, so there's that. Second to last one, when do you use loops and when do you use functions? They both have the same goal of getting rid of extra unnecessary code. But think about the way they work. Loops do exactly the same thing that you put in that loop, which is good, especially if you want to do 1,000 of them, but it can't be customized. Functions, you write one chunk of code and use parameters so that you don't have to, you can customize it every time you call. So it replaces the need for extra function definitions or extra, calling the exact same code over and over again, but it still would be limited if you wanted to do a significant number of repetitions. And so those are the differences, and they work together, though. You almost always have them together. I shouldn't say almost all. Those are 2 of like 6 main tools that you have. You will see them in almost every program somewhere. Okay, and the last one, design a program. It does say draw a single, well, it draws a white snowflake on a blue background. What do you need? What needs to be in your functions in order to create this? Okay, it's asking for top-down approach. I don't necessarily agree with forcing you to use a problem-solving approach. It's really more about the solution. But the point here is, how can you use functions and random numbers? I would say you would have the snowflake function call snowflake branches between 4 and 7 times, and the branches function would go out a random number of pixels in a range and do branches off of that, or something to that extent. Just talking about, you don't have to name your functions, draw all things, but having some sort of naming convention is your best bet. Okay, so that is it for the recap of Check for Understandings from lesson 9. We are going to start the new project. Please, screens off, phones away, headphones away, laptops close. This is at least a 2-day project, at least 2 full assignments. County planning guide, and I have the digital scene as like 10 points, but it probably should be more. It shouldn't really affect how hard you work on it. The new project is lesson 10 of the current unit. First things to clear up, there are several places in the overview and explanation that say things like groups or pairs or share. None of that applies to us. And the whole idea of any of the documents that are in the explanation, these documents, we are not using any of these documents. Code.org is not where you get the documents from for this class. You get the documents on the calendar spreadsheet. Okay. Any of the explanations in here, well, we will use almost all. I mean, we'll use, from what we've done so far, that we stick to the instructions pretty strictly between bubbles, but not entirely. You're responsible for the things we do in class if you're not here. Just jumping to the end and doing, just going through and seeing, oh, this is a shared project because that's what it says. No, it is not a shared project. And actually, I'm pretty clear. All aspects are original, or individual and original. Okay. On the calendar spreadsheet, you'll see this right here, which eventually will link to the instruction replay, which is actually being created as we speak. And this is the location for all the replays for those of you who have not been using them, which is, I don't want to say most of you aren't using them because most of you are in class, but this is where that will be shortly. Okay, so just an idea before we'll go into the details, the rubric, the planning guide, all that stuff. I'll try to do it as fast as we can. But to give you an idea, start thinking about what is possible. The project is an original digital, well, it's digital scene in that you're actually programming it, but it is similar to, or nearly identical to, the Under the Sea project, where you are creating multiple high and low level or complex creatures, or it doesn't have to be creatures or living things. And honestly, of the examples I'm showing you, they don't all meet every requirement, but they at least have some aspect that I want to explain. So which one is this one? This is a good one. This is an original one of mine. The rest are student projects. And this one has probably 5 or 6 different components that meet the requirement, I think. And it also has a time loop that you don't need to have it. It's essentially just restarting everything every click. But this one has birds, which are a slightly random sized, planes, which this is like a super advanced version of the fish. And they are random size, and they're actually random direction. And the mountains are in random places. Every one of your complex components, your creatures, if they're creatures, they could be mountains, doesn't have to have randomness entirely. Again, we'll talk about the requirements moving forward. But some more examples that load slowly. I want to find one that's not a actual landscape. So here's some panda and bamboo, and I think it would actually, I haven't seen this. If we call the bamboo first, the pandas won't be impaled by the bamboo. But some good things here. Obviously, the pandas are ending up in random locations, and one of them is good. So the high level function is actually pretty simple. The bamboo here is just a green line, and then jump back to the front and do tiny arcs, which would be extremely tedious if you were doing them individually, but because we have functions, it's a lot easier. Which one is this one? Okay, so here's some randomized grass with, it's essentially the seagrass, some flowers, wind, mountains, sun. It's not, doesn't have to be reinventing but it doesn't have to be a scene. Okay, so this one doesn't meet all the requirements in that there aren't as many draw all, but it's an example of something. It doesn't have to be like a landscape or looking out to the horizon. It can be, and most people will, which is a good one, or a very good one. Okay, so this one is pretty fantastic, I think. It has 10,000 loops, and it has two randomized components, I think. The location of all the light rays and the jump to that extra one. Most of these do meet most of the requirements, but let's talk about the rubric, which is available here from the calendar spreadsheet. Okay, so some basic organizational stuff at the beginning. I do want clean code. I want white space between function definitions. I want the definitions towards the bottom, or below the sort of general working space, so that it's easy to read. All you need to do is go to text mode, and you can put a space between things, but I usually, like when I start on a new thing, just put a bunch of lines, and then / is the same as a comment block, and it forces it to fill in the rest like that. Right? And comments, okay? Commenting your functions, definitions, what they do, you need to do that. The high level functions, I should put that. Comments are used consistently on, well, just function definitions. Function definitions. I can spell, I promise. Then, okay, so some other baseline stuff. Your functions and parameters need to have meaningful and descriptive names that indicate their purpose, even though both those things can be anything. The computer doesn't care. I care. Okay. Functions and abstract top-down design. Just like the Under the Sea program had draw all sea stars, which called draw sea stars. Draw all seagrass, called draw seagrass. Okay. Your program, your functions need to be set up like that. Now, every aspect of the scene isn't going to be that. You're probably going to start with some sort of background, which isn't, there's no like draw all background and draw background. And you can have extra things that are not high and low level. Like my son is, well, does it have a draw all? No, it's not a high and low level function. It's just draw one. It does jump to a random location each time. Oh, it's supposed to, a left, right. Never mind. Every aspect doesn't need to be high and low level, but you need 3 examples of high and low level functions. Okay. You need at least one, and it doesn't say 3 here, but we'll get to it right here. At least one of your functions needs to receive a parameter, and of course, send it when it's called, send a value when it's called. Every single one of the creatures from the Under the Sea had at least one parameter. You can do that also, but it's at least one function needs to receive a parameter. Loops are used consistently, which any of the draw alls is going to be have a loop. Okay. At least 2 examples of using the random number block. Every single one of the Under the Sea creatures did that. And you need 3 or more separate, complex, multi-level / abstraction. Is that not a word? Fine for me. And abstraction is a word. Okay. Plus the background or ground. Okay. That is the rubric. Let's talk about the planning guide Okay, the planning guide, that is due today, and it shouldn't take you terribly long. This is a Google Doc assignment that you will submit to Canvas, the assignment that already exists. Okay, and so the planning guide. Before you begin, make sure you review the submission guidelines and rubric, which we just did, so you're good. Pick a scene that has the following features. Okay, several components that allow it to be broken into logical chunks. Okay, repeated elements that will allow you to use loops and random values, and at least one function with a parameter, so that you know, size, color, what have you. Although I guess size and dimensions are the same. Here you're coming up with your three components. Think about what you're seeing, what makes sense. Technically, it doesn't have to be a logical, you know, scene that you could possibly see, but it's easier if you just sort of think of a general landscape and the things you would see. There are other possibilities than landscape. It could be something abstract. It could be, I don't know, I see space a lot. I see trees a lot. I see, I don't know, whatever you want. Okay. So once you have your three components, you're going to get a blank sheet of paper, which is provided at the front of the room, and a pencil, and you're going to do a light sketch of what your scene is going to look like, specifically these three components, their general shape. You're going to take a picture of that sketch on the blank paper that you did with pencil, and that you wrote your name, date, and period at the top of. You're going to do that before you start sketching. And your drawing should include some brief annotations and like saying what the things are, or I don't know, just if you are not a good artist, you can use annotations to clear things up. And when you're done, you're going to take a picture of it and insert that picture into this space, which you need to be able to figure out. That's like as good a thing to learn as anything, being able to manipulate and move digital files to different things. Okay. And here is where you're going to identify, like write out what are your function names actually going to be and what are they going to do, that sort of thing. Okay, that is not too hard. That is due today. That is not, that is something that you're going to submit to Canvas. I can't imagine taking more than 15 minutes, 20 minutes, but when you're done and submit it, only once you submit it, can you go on to the actual project, which the project, if you look at lesson 10, there is bubble 2, which is a open form, an open canvas, I want to say, but that's not the right word, an open app lab project that allows you to get to all of the blocks that you need, but you aren't going to do it in bubble 2. You're going to do it in bubble 4. Don't worry about why, just, well, the why is it makes it easier for me to go through things, and less likely for you to be marked as not having submitted it. Okay. This is where you're going to do your work. And if you're ever not sure, there's usually something in the explanations, like use lesson 10 bubble 4. That is a digital scene with multiple components. What do you mean? What's the question? No, you don't. You can completely ignore bubble 2. If we were doing it as a multi-stage situation, it is how you would sort of collect things, but we are not doing a multi-person situation. 3 is an explanation of how to get code from bubble 2 to bubble 4. You can see it's a square that it's not a to-do thing. Here's another example of a reasonable complexity situation. Birds and waves seem to be a very similar shape, except inverted. This one, I'm pretty sure the clouds are in random places. Yeah, sun's always in the top left, which is fine. These umbrellas are not ideal, except it's clear they're umbrellas, which that's what we're looking for. And so that's a, beach scene is super common, as long as your stuff is original. There are walkthroughs online for examples of this project. I have seen every single one of them. I've made several of them. Some of them are copies of my work, actually, from other teachers, which is fine. And where they're demonstrating the thing that I made, which I have no problem with. This is not proprietary. I'm not trying to copyright it or have any sort of intellectual property over it. It's fine. You cannot submit any of those work, any of those existing things. Okay, I've put this a bunch of places. All aspects are individual and original. It is the original digital scene, digital scene. Okay, so I'm sure there'll be tons of clarification along the way, but you can start now. Go ahead and turn your screens on. Get a copy of your original digital scene, complete that, including the sketch that's inserted into that document before you go. I know I didn't explain that before I opened up the thing. Before you go and start your actual drawing, because that's how planning guides work. Okay, any questions right now? I can put I'll scroll through some of this code so that you can at least have an idea of what's going on. And you can pause it in the replay. Let's go. Okay, so this is the B one that's receiving a bunch of stuff. I'll try to go slow through this so that it's not blurry. If you want to pause it, scrub through. Some of the stuff is kind of advanced or uses variables and stuff, which we haven't done. And almost all of these lack white space between function definitions and are a little messy because I haven't made it a requirement in the past, but now it's a requirement. So this is the sushi scene that is not successful at meeting all the requirements for this project, but it is I think a completely different concept than I'd seen before. A table setting. This is the whatever you want to call it, sunbeam that does 10,000 loops and it takes forever. Is it still going? I don't know why it's going slow. So there's that. And if you're not sure how to do things, okay, so this is my digital scene, and this one has a lot of commented out code, which is just aspects that I made but didn't end up using. So that's what it means if it's grayed out. This one has a lot of use of variables. That's really the easiest way to make those complex things, keep track of different things, which we haven't done, but that's fine. I don't expect you to use variables yet. And wow, this is insane. That is the code for the planes. Sizeness is a positive or negative. Let's see, which one is this? This is the pandas and the bamboos, which I am going to go ahead just for their own safety. Put the bamboos first, which is a good tip. It draws back to front. So that's why that does that. Because these top level functions, the top level function calls are these top level function calls are up here at the top, which is your best bet, because you can do things like rearrange things or comment out one of them as a way of debugging. When you are figuring things out, you can comment one out, which is just switch to text and do Control/ or put 2 slashes at the beginning of the text line, and it will let you work on some aspect of it instead of the other. And I can't remember if I scrolled through this yet. Draw a leaf, draw a panda, draw all bamboo, draw bamboo. This one is much closer than the other ones to meeting the, wow, the draw panda one, that is a lot of code, but you've done all this stuff. It's just doing more of it. This one is a lot closer to meeting the requirements than the other ones. I'm not positive, actually. I think it might. I'm just not, I don't want to present these as these are all 100% projects. They aren't. Although this one might. I need to go through. I think it probably does, because 3 components. It has the bamboo from before, the pandas, which are very impressive, and there's some sort of like grass or something on the ground there. So I'll scroll through this again, so it'll be in the replay. And that one, wow, that has a lot of stuff. And I think this actually has a 3-tier one, because the draw panda, which is, there's got to be a way to shrink this code, but it's fine, it works. Draw panda calls draw eat, which is this super low level function, which is, that's fine, that's great, that's how it's supposed to work. What is what? Camel case just means when you're writing out function definition, each word starts with a capital letter. And this last one, which is the sort of pastoral scene, the program code looks like this. Draw clouds, draw sun, which is hard-coded, that's fine, the sun's always in that corner. Yeah, this one is good, but I don't think it breaks it up into layers the way that it should. Your best example is the under the sea scene from lesson 9. As far as a project that meets the requirements, whatever was the, I don't know, before you did something wild, well, you probably didn't break it that much on the last bubble of lesson 9. Oh wait, that's lesson 8. What am I doing? Lesson 9 looks like this. Yeah, so this is essentially the digital, or excuse me, the under the sea scene, but your own stuff. You can do a different under the sea. Oh, is this one? Yeah, it is this one. You can do a different underwater one if you want, as long as it's original. I mean, you can use fish as long as they're different fish. But the way this is set up with all the high level functions, draw all, draw all, draw all, and then the lower level functions, draw one below that, and then the top level function calls are all at the top. This is a great setup because you can reorganize them. Like I said before, you can mess around with them a lot easier and more easily, and turn them off and whatnot. Okay, so let me know if you have any questions. That's it.